Hey there, folks. It is November 9th, and we're going to be looking at two chapters today, but I'll do two separate videos. This will be the first. This is chapter 19. We're going to look at groundwater. Um, Again, it's one of those chapters where there's a lot of good information, and you definitely need to read it. There'll be a little bit of it on the test, but there's not a huge amount of material in here that you need to commit to memory. So I'm going to kind of go through it quickly and just kind of hit the highlights. Um, but definitely read the chapter and um, but don't panic too much if there's too much detail. Kind of cut through it, but I'll go through the basic stuff here. So let's jump right into it. This is chapter 19, and we're looking at groundwater. And of course, when we talk about water, we're talking about, for groundwater, we're mainly talking about fresh water. There can be groundwater that's saline, it's salty. It can have sulfur in it. It can have all kinds of things. So we'll talk about that in more detail. But generally, when we're talking about groundwater, we're talking about water that's in the Earth's crust and trapped because of the rock. Rock is porous, and so the water gets stuck in these porous areas. Sometimes there's large caverns. We'll talk about those in more detail, but again, this is where we get a lot of our water, especially nowadays, where a long time ago, if you were getting ready to build a house or something, you might build it right next to a river or something to get water. Of course, today, and living in a city, and up till quite some time living in cities, you needed to get water from other sources like a well. And so today we would dig wells. Of course, today with modern science, we have water pumped to us, but that water has to come from somewhere, and a lot of that water also comes from groundwater sources. Um, so anyway, we talk about groundwater. Your book starts talking about some of the situations in Florida where the groundwater can actually eat away. The acidity of the water eats away at the limestone of the rock and can actually create these sinkholes. And so this shows up on the news every now and then when someone's built a house or built something that they thought was pretty solid, and then all of a sudden a sinkhole opens up. And some of them are, I mean, people have died because these things have happened. So it's not anything to really laugh about, but it is unusual, and we don't have to worry too much about that happening in Kentucky, but they are having quite a problem in Florida where the ground is a little bit more unstable. So here's some of those sinkholes that we've seen in Florida. So the rock itself, or the water itself, comes from rainwater. It comes from surface water. A lot of the surface water, of course, is carried off in rivers to lakes and that sort of thing. But a lot of the surface water lands in the soil and gets absorbed by the soil, and some of it will reside in the ground as groundwater. And that will change quite a bit. The groundwater can rise and lower. We call this the water table. And the water table, at times when it's not been raining for a while, the water table can drop precipitously. And other times when it has rained a lot, the water table can come up. But that has a lot to do with the soil and with the rock, talking about its porosity, its ability to move water, the number of holes and interconnected holes within the water. And here your book shows a little description of how that happens. So sometimes the water can move freely, and other times it kind of gets trapped, and that's really a big part of what we're looking at. Where you do have large amounts of water, we call these aquifers. Louisville has a large aquifer under it where we used to get groundwater quite a bit. Now I believe the water company uses uses an aquifer, uh, but uses it sort of as an initial filtering device, and then pumps the water from the aquifer. Well, it goes from the river to the aquifer, from the aquifer to the water company, and then they do final treatment and send it out to everybody. So uh, we do get our water technically from the Ohio River, but it does come through a sort of a natural filtering device. That's what aquifers do. Um, and that's how we get our water. If you're getting city water, the book shows here how aquifers are formed and how this can happen. There's a huge one out west, which is being quickly drained, as we'll talk about later, by the large cities out there. You see these all over the place, and they are great for, again, uh, getting to the water, but we have to be careful as to how we use them. Your book here talks about the water table. We've already discussed it a little bit, how it can rise and fall. So a lot of times in the springtime, when there's a lot of water, you'll see a lot of puddles on the ground, even after it's rained. But a lot of times in the fall, when it's dry, and we do get a rain, the puddles seem to go away quickly because the water table is much lower. The water quickly evaporates or is absorbed into the soil, and so we don't see them as often. Um, Groundwater can flow, just like they're like underground rivers. They can change whether or not, again, they're full of water or not full of water. And again, this water is coming from rainwaters, rain, you know, percolating into the ground. And so aquifers need to be what we call recharged. And so this recharge area is an area where it gets lots of rain, and then the discharge area is where a creek might be or where someone's pumping water out artificially. And so this can cause quite a few changes in how groundwater flows and where groundwater is at any one particular time. Now, again, as the water moves to the ground, we think the water is going to get dirty, right? But in fact, what's happening is um, that the rock and the soil and those sorts of things are actually cleaning water. So when you get water, groundwater from like a spring or a well that we'll talk about in a little bit, it's actually been kind of cleaned up and filtered. And so groundwater can be safe to drink and actually very clear, clean water, even though maybe it was polluted on the surface. You may have someone who lives out in the country and uses wells, and they say their water is hard. What they're talking about there is that the water has minerals in it that, if you've ever been or lived in a house with hard water, a lot of times you'll see rings around toilets where the water, it's hard to clean off, bathtubs, that sort of thing. And sometimes the water will even taste different. You can taste some of these minerals, especially things like salt, calcium, magnesium, and sulfur, can give the water a different kind of taste. So sometimes you can actually taste the minerals. Springs, we said, were places where the water comes to the surface. And so these are springs. There are different kinds of springs. There's flowing springs, and then springs that, again, will flow at certain times or be dry at other times. Um, you may have seen some of these out in the country. Um, could be a series of rocks that are broken and water's coming out of them. And so these are places where the water table is high enough and there's enough crack that we get flowing water. Now, most of the time when we need water, we've dug a well. And so a well is basically digging a hole down into the water table. And then the well will fill up with water, and then you can get it out by either dropping a bucket and pulling out the water, or you can use a pump and pump water out that way. So there's a lot of wells. Again, once you get away from the city, most of the people get their water this way with a well, and a lot of this water is hard water, so you have to have a treatment device in order to use it generally. But it is perfectly safe water. You don't really have to do much more to it than just pump it out and use it. Um, you've heard of or seen or maybe even been to some hot springs. Excuse me. So hot springs and geysers. Hot springs are generally places where the water is close enough to some sort of volcanic activity or some sort of geothermal region. It causes the water to be heated up, and so the water comes up at a higher temperature. Um, and so we see these a lot of times in different places. They're very popular, of course. Geysers happen because the water gets trapped under pressure. and that heat or that water can come out at a high volume, come spraying out. And of course, we think of Yellowstone National Park, and of course, here's Old Faithful Geyser in Yellowstone. And so we see geysers caused by groundwater too close to some sort of geothermal event. Um, then we look at problems. So, of course, groundwater is great as long as people aren't involved. But as soon as people start living in places, they pollute the ground. They don't take care of stuff on the ground. So then, of course, when water hits and goes down in the ground, it takes these pollutants with them. A lot of times the ground can filter them out, but in a lot of cases, there's too much or the filtering is not enough. And so things like chemicals, um, things like fertilizers, things like just general pollution. We barrels of oil or just any kind of industrial waste that's left to just sit out will and can enter groundwater, can enter aquifers and cause real problems. Also, saline intrusion, for example, salt water. So if you take out all the fresh water may have been under enough pressure to block out the introduction of salt water, especially if you live near the coast or you live near somewhere where you have a salty sea or ocean. And then that salt water can come in and cause problems. So again, there's not a problem generally until people get involved, and then all of a sudden, that water that we were using gets polluted, and so now the water can't be used or has to be treated before it can be used. So these are always issues that we have to deal with. One is just taking the water away. Here's a sense where as you remove water, if you don't, in other words, as you discharge water artificially and don't allow it to recharge, the ground is literally going to drop. And so this is an amazing picture of where the ground was in 1925. So where this guy was standing, this dirt was here in 1925. As they started taking out water underneath the aquifer, this whole area began to sink. Here it was in 1955, and then whenever this picture was taken, 1977, I guess, this is where the ground is today. So yeah, it's a big deal taking water out, and of course putting water in, having an issue with rising sea levels and that sort of thing can affect cities like Venice, where now the water is getting higher and higher. People used to live down here on the first floor, and now the second floor has become the first floor because all of this is now underwater. So um, the groundwater again is very fluid, not to put too much of a joke on it, where water levels can go up and water levels can go down depending on climate conditions and depending on what we do. So we have to be careful, don't we, about what we do and where we do it. Um, your book goes in here a little bit on how to take care of groundwater. Then we jump into caves and karst topography, which is important because we live in an area that has this karst topography, and it's basically limestone. And we know that limestone then can be dissolved by water that's slightly acidic, and so we have lots of caves in this area. Of course, we know we have uh, we have Mammoth Cave, the largest cave system in the world. Um, but we have lots of caves in and around Louisville, and a lot in the area. And so this is what we mean by karst topography. Now it's a little bit different than Florida, so we get a lot of this uh, water dissolving these sorts of areas, but they're more in Florida. You have sort of a layer of sand and stuff on top of it, so the sand acts as sort of a bridge until it collapses, and that's where the sinkholes come from. Here we don't have that sand; we just have the rock, and so when a sinkhole develops, it's pretty obvious. You don't build where there's a big hole. But anyway, yeah, we have a lot of caves around, and that's caused by groundwater. And here you can see folks in a cave. And if you've ever been in a cave, it's pretty cool to do. You should definitely take a trip to Mammoth Cave um, and see that. Here you can see a river literally disappearing. It's going down into a cave, and then somewhere along the path it will pop out, and you'll see the river again. And so that's what we mean by karst topography. Lots of different animals live in these kinds of landscapes. Most of them don't need their eyes anymore, so we don't. They're blind. Here you can see kind of how that develops. And almost any cave, when you go deep enough, you're going to run into water, um, because that's what caused the cave to be formed in the first place. Excuse me. So this is groundwater. Again, it's a kind of a short chapter to read, but definitely read it because it is important. It's probably where you're getting your water that you're drinking right now. And even if you drink bottled water, you're probably drinking water that came from some spring or uh, some well somewhere. And it's important to understand how to keep that clean. Here are your review questions on pages here, 727. And so do those if you want. And look for the second video, which will be coming up very shortly.